normal reaction minus the weight, because they are moving upwards, so it's normal reaction minus the weight. So all these three cases, normal reaction minus the weight, normal reaction minus the weight, and normal reaction minus the weight. But the only difference is the net force, they are different. One time the net force is positive, one time the net force is zero, and the last one, the net force is a negative MA. So, okay, so we start off by using net force equals to normal reaction minus the weight, the mg. Okay, right. Now, what happens when the leaf is moving downwards? When the leaf is moving downwards. So again, for the case where the leaf is moving, when the leaf is moving downwards, we can have three cases. The leaf is moving downward, right, with acceleration. The leaf is moving downward with acceleration. The lift is moving downward with constant velocity, and the lift is moving downward with deceleration. Okay, so we can have three cases again. Moving up, three cases. Moving down, we have three possible cases. Can you still remember how to start the equation? Which equation to start with?
Uh, I don't think so. Can you say again?
We start off by using the net force. The net force is equal to the bigger force minus the smaller force.
Okay,
Okay,
that was
now we are moving downwards. So who is bigger? The weight is bigger than the normal reaction, right? The
okay.
weight is bigger. There are only two forces acting on the object, the weight and the normal reaction. So since we are moving downwards,
Hmm.
we are in the same direction as the mg. So the net force will be the mg minus the normal force, the weight minus the normal force. So in all the three cases that are moving downwards, we use the weight minus the normal force. Weight minus the normal force, weight minus the normal force, because we are moving in the same direction as the weight. We are moving in the same direction as the weight. So we start off by having net force. Net force is the weight minus the normal force. Here also we say net force is the weight minus the normal force. Here also we say net force is the weight minus the normal force. Okay. Now in the first case, if it is accelerating downwards, the net force is equals to ma. Ma equals to the weight minus the normal force. So we try to make the normal force the subject of the formula. So move the n over, it become positive n. The ma move over to the right hand side, so we have the mg minus ma. So in the case when the leaf is accelerating downwards, the normal force is mg minus ma, okay, which is the which is the weight minus the mass times the acceleration when it is accelerating downwards. So how to start off the second case? We use the net force, right? What is the net force equals to, Joel? Net force is equals to what?
Uh,
The bigger one, because it's moving downward, the bigger one is what?
mg,
Mg. Minus which one?
the Newton. Then
The normal reaction n, right?
hmm.
So the net force is the downward force minus the upward force, because we are
Upward
moving
force.
downwards. So the bigger one will be the downward force, because the leaf is moving downwards, right? So we
Mm-hmm.
say the net force is mg minus n.
Plus N.
N is the normal reaction.
Mm-hmm.
So, but we are moving with constant velocity. So according to Newton's first law, constant velocity, the net force is zero. So we equate this mg minus n with zero. So when we make n the subject of the formula, we notice that n is equals to mg. Okay, why is it like that? When we compare with our experience inside the leaf, so when the leaf is moving with constant velocity, we actually don't feel more pressure on the feet or less pressure on the feet against the floor of the leaf. Whether we are moving upward or downward with constant velocity, we feel that as if it is not moving. We feel our feet don't feel more pressure or less pressure. They feel it's the same. The reason is because the net force is zero. So when the net force is zero, the weight and the normal reaction, they are both equal. They are both equal. Any questions so far?
No.
No. So how to start off the third case? The third case, net force equals to what?
Net force equals to uh negative MA, which equals to downward force minus upward force.
Correct. It is always the weight minus the normal reaction. Or that will be the net force. And the net force is actually negative because it is slowing down. So the net force is negative. So when you make n the subject of the formula, you move the n over to the left hand side. MA you move to the left hand side. You know that the normal reaction is the weight plus the MA. Okay, the weight plus the MA. So next time, how to start off the equation? By using the net force. If it is moving upward, net force is the normal reaction minus the weight. If it is moving downward, the net force is the weight minus the normal reaction. So you start off with this equation, then you are able to derive a general formula for the normal reaction. Okay, any question with this inside the lift?
No.
No, no. And we continue with the next case.